For most valuers, site inspections are a common occurrence. Perhaps because of this, it's easy to take them a little for granted. While the degree of inspection is ultimately a matter for each valuer's professional judgment, a greater awareness of the various influential factors can only benefit valuers and their clients. Because site inspections cover a broad area, we'll concentrate on those aspects that tend to have the greatest effect on the valuation. In most cases, these are defects of materials, workmanship and preparation. And we'll look at them in terms of existing dwellings and those still under construction.
Whether the properties are new or old, one of the first challenges can be locating the boundary pegs. The right ones, that is. It's a little unwise to simply assume the builders are using the correct ones. Buildings have been known to end up on the wrong site completely or wrongly placed within the site. To avoid overlooking important site details, a checklist can come in handy. Such a checklist could include the certificate of title indicating boundaries, easements, access and rights of way. The local authority plan establishing for the valuer the services supplied to the site. Outbuildings such as garages and other buildings of permanent construction. Hazards such as the potential for flooding or other water-related problems or land instability. And the nature and state of adjoining properties and the general neighbourhood. As mentioned in the video on foundations, trees, soil types and excavation work can also have a bearing on site suitability. And at the root of many site problems, moisture in one form or another.
Because moisture problems are widespread, it's important to determine whether there are aspects of the site topography or the structure itself that are likely to cause any difficulties. Incorrect land levels are a fairly common occurrence. Here, for instance, the soil beneath the house is lower than the area surrounding it. So naturally, water collects here and can cause dampness.
For undulating or sloping sites or those with difficult soils, adequate provision for drainage is essential, and this should be shown in the plans. But if you're in any doubt, it's worth seeking further advice.
Some problems will be less obvious in certain weather conditions, so it's not a bad idea to make a note of what the weather was like during the inspection, so you can refer back to it if necessary.
And what do the neighbours think? In other circumstances, you might not care too much, but a quick chat can be quite revealing, provided you verify it.
How deep is that? Valuers are likely to have to examine plans and specifications for the approval of loan finance before a building is built, and for progress payments once the building is underway. Unfortunately, many of these are overweight. They contain a lot of irrelevant or superfluous information. To focus on the material which is relevant, it helps to go through the specifications beforehand with a marker pen. While we're talking about written material, there are another couple of publications that are useful to refer to when it comes to structures. There are numerous building standards, but this is the one you are likely to refer to most often. New Zealand Standard 3604/1990. Code of practice for light timber frame buildings not requiring specific design.
Most valuers are familiar with common building terms like studs and dwangs, but what about wire dogs or frogs? That's where this little chap really comes in handy, the Standards Association's Glossary of Building Terminology. I imagine it's got quite a bit on the subject of timber. By far the most common framing material in New Zealand is timber. Because of its rapid growth, pricing and versatility, radiata pine provides the bulk of it.
Being a natural product, timber is subject to variations which affect its suitability for particular end uses. New Zealand Standard 3631 establishes the type, size and number of defects allowed in the timber and grades them accordingly.
The framing timber we're concerned with is designed for structural purposes, where strength and stiffness is required.
Within the framing group, the number of knots will usually determine whether the timber is number 1 framing, which is more suitable for studs, or number 2 framing, which is more appropriate for dwangs.
Testing clearly shows that excessive knots considerably reduce the structural strength of timber. This is particularly important in load-bearing situations. The knots in these bearers, for instance, have weakened them, causing them to sag. Framing timber doesn't necessarily have to be dead straight to be acceptable, but obviously, timber that is badly warped or twisted isn't going to make good framing.
Nor is timber that is too moist when it's enclosed. In fact, it's imperative that the moisture level, which is about 50% by weight of radiata pine when it's felled, is reduced to between 18 and 24% before internal linings are fitted.
Builders will frequently fit framing timber which still has to reach the correct moisture level, then fit the exterior cladding, but leave the interior lining off so that ventilation can do the final drying.
Treatment provides protection against insects, moisture and other specific environments that are potentially harmful to timber. It's very important that the type of treatment matches the end use.
This branding shows the hazard class, the registration of the treatment plant, and the woodmark symbol, indicating the plant is approved by the Timber Preservation Council, who, by the way, produced this leaflet showing the various hazard classes. When valuers inspect new buildings, they want to ensure that the size, shape and construction match the building's approved plans. For accuracy, nothing measures up to this. The first thing to strike you about the framing is likely to be whether the vertical and horizontal planes are true. These ones are fine, but if many of them aren't, it's a fairly safe bet there'll be other shortcomings.
For example, nails roughly hammered in or splitting the timber, incorrect or inadequate fastenings, insufficient dwangs for the type of linings to be used, or poorly graded timber.
Other trades can also be guilty of damaging the structural strength of buildings. This plumber wouldn't let anything get in his way.
To provide the structural strength needed to resist lateral forces like winds and earthquake, buildings need to be properly braced. And that bracing needs to be a total package, from the foundations right up to the roof.
These days, most bracing strength comes from sheet products, like this.
However, to be effective, they have to be extensively nailed to every stud and dwang they cross.
Diagonal metal or wooden braces inset into the studs are another common form of bracing. They should be well fixed, not too steep, and continuous from top to bottom plate, unlike this example. Shortcuts like this can seriously reduce the bracing strength, and the design of these windows makes effective bracing extremely difficult.
Normally, the type of bracing is outlined in the bracing plan and the specification. But if the job looks inadequate, a call to the local authority should clarify the matter. Building papers are designed to prevent rain or drafts entering, but also to allow vapour to exit. However, they're not going to do the job properly if they're badly punctured or torn. Damage is most likely to occur when the cladding goes on, especially when ties are attached to brick veneer. Vapour barriers, like reflective foil on the other hand, are designed to prevent moisture from within the house getting into the cavity. They also have value as an insulation material.
This dual moisture barrier insulation roll also applies to products which sandwich an insulating foam between two layers of foil. These, however, are generally fitted on the exterior side of the framing. Identifying structural problems in existing houses can be a bit more difficult to trace, unless they are severe. However, there are often pointers which warrant closer inspection. One of the first tools you use when you enter a house for an internal inspection is your nose. A musty smell, for instance, will tell you that there's probably excess moisture trapped somewhere in the house. Mould is often the result of poor ventilation. When you think that the average household produces 12 litres of air vapour every day, that's a lot to get rid of. In most cases, it can be expelled simply by opening a few windows. But problems can occur with things like clothes dryers, which produce large amounts of air vapour not being vented to the outside, and ventilators, like this, which merely push the air vapour up into the ceiling or roof space. But where ventilation doesn't appear to be a problem, a little more probing is probably justified. If the mould seems to occur in front of the studs, especially in newer houses, it's quite possible that the framing timber wasn't sufficiently dry when it was enclosed. This factor can also lead to shrinkage and warping, which can cause walls to tilt or bulge. But distorted walls can also result from the use of poor grade timber, or foundations settling in one spot and taking nearby studs down with them. Pointers to settlement could also include cracked scotia or wallpaper, uneven floors or jamming doors or windows. This aspect is well covered in the foundations video and accompanying booklet, Digging a Little Deeper. It's important for valuers to realise that whether these sorts of problems weaken the structure or not, they will be time-consuming and costly to remedy. Unorthodox work like this is usually the trademark of the amateur do-it-yourselfer. Some of these can be downright dangerous. And some products seem to have almost been designed for cover-ups. Extra-wide mouldings, for instance, and textured finishes and papers can hide a multitude of sins beneath. A cracked or split windowsill can be a sign that the trimmer underneath isn't rigid enough to prevent the sill flexing. and bowed ceilings can result from joists which have either sagged or have uneven undersides. The main purpose of insulation is to isolate the walls, ceilings and floor from the outside air, and thus provide the occupants with added warmth in winter and coolness in summer. The insulating material varies from slab form like this, to sheets, to loose fill and sprayed materials. Thoroughness is the key to good insulation. That means firstly that all surfaces are insulated, ceilings, walls and floors. With houses built after 1977, insulation was mandatory. If the house you're inspecting is older than that, you may have to do a little investigating to ensure that insulation exists. In the subfloor area, perforated reflective foil placed between the joists serves a dual role as an insulating material and also a means of getting rid of moisture. In walls, you can have the whole range of insulating materials, but the important thing is that they are evenly distributed. You only need a very small gap to seriously reduce the insulating value. Of course, when the walls are lined, especially in older houses, how do we know there is insulation behind? Well, one way of checking is to remove a hot point or switch plate. Roof spaces, like basements, are not always easy to get into. But if there are problem indicators like bad ceiling condensation or ventilators that just go into the roof space, and access isn't too difficult, it could be worth a look. And if you do go to all this trouble, don't just have a quick feel around. Have a good look with a torch. You could be surprised what you'll find. Valuers aren't expected to have the skills of engineers, architects or surveyors. This expertise can be sought if the inspection justifies it, and information can always be obtained from specialist organisations like the Standards Association, brands, and your local body building inspectors. But for the good of your clients, you should have an appreciation of the basic components of residential buildings and sites, and above all, keen observation.